In the last video, we looked at the set of all outcomes for the throw of a fair die. Those outcomes are the numbers 1 to 6. We saw that each of these outcomes is equally likely or equiprobable. We called the set of all such outcomes of a trial U. Now we're going to denote the set of outcomes of a trial by the letter S in this video, and we're going to call this the sample space. Now, the set of all possible outcomes do not have to be equally likely, but very often they will be. Probably most of the time, or if not all the examples we do, will involve outcomes that are equally likely when we're discussing Venn diagrams and probability. In this example, we're going to take an experiment which involves two throws of a fair kind, and both throws or trials are more or less identical, or as identical as practically possible. We are going to list the sample space for the outcomes of both throws, not just one throw. So, in previous videos we were just looking at outcomes of a single trial. Now we will combine more than one trial together. In this case we're combining two throws together, so we're combining two trials together. And in the first throw or trial, the outcomes are H or T. H for heads, T for tails. So there are two possible outcomes for the first throw, and for each of these possible outcomes for the first throw, we have two possible outcomes for the second throw. So for each of these two ways, we have two ways for the second throw. So we have two outcomes, or two ways that the first throw can come up, can be heads or tails, and we have two ways that the second throw can appear. So by the fundamental principle of counting, we have 2 times 2 equals 4 ways that two kinds, or a kind can appear in two throws. We could be actually talking about two fair kinds both being tossed together, but I just want to refer to two different trials of an experiment here, so I'm just going to think about one kind being tossed twice. So we're going to use set notation. S, capital S denotes the sample space. We're going to use the chain brackets, and we're going to write down each outcome separated by commas. So one possible outcome is HH. So we're talking about one outcome of two throws of a fair kind. So HH is just considered to be one outcome. If H is first, then tails could be second. So if H is first, we can either have HH or H tails, and that's it. Now we need to go to a new outcome where tails could be first. So if tails is first, then we have two ways to select the second throw. We could have tails heads or tails tails. So we have 4 elements in the set S. So the number of elements in the set S, we can write it like this, or sometimes you'll see it written like this, is 4. We could show these elements on an Argand diagram. We could draw a rectangle to represent the set S. And a dot represents each outcome. So we're going to have 4 dots. And we write the name of the outcome next to the dot. Now an important question that we could ask is, are these outcomes equally likely? Well, we have no reason to suppose that they're not. We have no reason to suppose that getting 2 heads is more likely or less likely than getting 2 tails, or head first, tail second, or tails first, head second. We have no reason to suppose that. We're dealing with a fair kind, and we're dealing with 2 identical throws. Also, the result of the first throw has no effect on the result of the second throw. So if we get heads in the first throw, it should not affect the probability of getting heads in the second throw. The probability of getting heads in any throw should be a half if we're dealing with a fair kind, as we saw from the last video. And the probability of getting heads for the second throw should also be a half. So we're dealing with independent trials. So each outcome consists of 2 independent trials. So the result of the second throw does not depend on the result of the first throw. Let's suppose that the trials were not independent. Let's suppose that the trials were dependent. Let's suppose that getting heads on the first throw somehow increases the probability of getting heads on the second throw. So if these events are truly independent, then the probability of getting heads in the second throw should be a half. But let's suppose that the probability is more than a half if we've thrown heads on the first throw. So we're dealing with dependent events here. Well, if that was the case, then this outcome would be more likely than this outcome down here. Because here, the first throw gives tails. And the probability of getting heads after tails has been thrown would actually be less than this combination up here. Because we were supposing that getting heads on the first throw increases the probability of getting heads on the second throw. So we're more likely to get this combination than this combination here. So we're supposing that all trials are independent. Well, there's only two trials here. So each of these four outcomes are equally likely. So we could have called this set U. I used the letter U in the last video to denote the set of all equally likely outcomes of a trial. But we're going to stick with the letter S for sample space from now on. And most of the problems, if not all the problems, will involve equally likely outcomes of a trial, or equiprobable outcomes. Suppose that after the two throws of a fair coin, we are interested in the probability of getting two tails. Well, since we're dealing with equally likely outcomes, we just take the event that consists of two tails. Well, that's just an event consisting of one element. We look at, well, the number of elements in it is 1. So let's call the event TT, and we want the probability of it. So we see that this event consists of just one element. We put the number of elements that are in the event, as we saw in the last video, over the total number of elements in the universal set, or S in this case, which is 4. So the answer is 1/4. Let's look at this answer a bit more closely. We know that half of the outcomes of throwing two fair coins consist of tails for the first throw. Now, I'm going to call the event of getting tails for the first throw T1, and I'm going to circle that event. So I'm going to call this T1 for obvious reasons. The 1 means we're getting a tails for the first throw of the two throws. So this event consists of two outcomes, tails or tails heads. We also see that half of the outcomes consist of tails for the second throw. That's not surprising, because the probability of getting tails is a half. So half the time tails will appear for the second throw. I'm going to call the event of getting tails for the second throw T2. Tails for the second throw looks like this. This is the set T2, or the event T2. Well, we can see from the Venn diagram that the event TT, which just consists of a single element, this element here, is the intersection of the set T2 and T1. So the probability of getting two tails, which we've calculated already, but I just want to look at set notation for it. Well, we know that this answer is 1/4. We've seen that already. But we can arrive at 1/4 by multiplying the probability of T2 by the probability of T1. So that's a half times a half, which we know, as we've seen already, is 1/4. The probability of tails on the second throw is a half. It's just the probability of getting tails on any throw is a half. So you see that we multiply the probabilities for the probability of getting two tails. We get a smaller probability than a half. Now that's not surprising. It should be less likely to get two tails in a row than to just get one tail from the throw of a coin. So we would expect this number to be less than these numbers. So we certainly won't be adding these probabilities. Another way we can look at this is to say that half of all the outcomes consist of tails for the first throw. Well, there are 4 outcomes. So 2 outcomes consist of tails for the first throw. And half of these outcomes consist of tails for the second throw. Well, half of 2 is 1. So we have 1 outcome out of 4 that consists of tails for the first throw and tails for the second throw. So half of those outcomes that consist of tails for the first throw will consist of tails for the second throw. So we've half of a half, or quarter of all the outcomes, consists of tails for both throws. We can also think of the intersection of 2 sets as the AND operator. So we want the probability of tails on the second throw and tails on the first throw. T1 and T2 are independent events, so getting tails on the first throw does not affect the probability of getting tails on the second throw. And when we're dealing with independent events, we multiply the probabilities together. So in general, if A and B are independent events, then the probability of A and B, or the intersection of the sets representing the events A and B, is the probability of A multiplied by the probability of B.